you write a equals 3, what happens in the background is basically your Python interpreter creates an object, integer object of 3 in the memory, and the variable a points to that object. Okay, so a points to 3. Then another thing is in Python, when you say b equals a, basically when you assign something, it does not create a new object. They simply point to that same object in the memory. So when you say b equals a, what happens is the already existing object of 3 is also pointed by b along with a. So now both a and b are pointing to 3, same object. Okay, this is basically done to some save some space. This is done for memory management. Okay, and then finally when you say a equals string, now what happens is another object high is created and a points to that, and the pointing of 3 from a is removed. Okay, so now a points to high and b points to 3. Okay, so basically all of the integers or strings, these are immutable objects. The objects themselves don't change. Okay, every time you assign it to something new, a new object is created, and if the object already exists, like this for example 3, then it points to the same object. Okay, so now we come to our concept of shallow copy. Okay, so basically our integers and strings are immutables, but the problem with lists is lists are mutables. Okay, so basically when you say a equals 3, b equals a, and then again assign a to something else, b does not reflect the change that was made to a. But in case of lists, if you create list 1, assign list 2 as list 1, list 2 equals list 1 simply, and when you make changes in list 1, it will also make changes in list 2, because both of them are pointing to same list, and when list 1 is changed, being mutable, the list itself changes. Rather than creating a new object in like in case of 3 and string high, a new object of string high was created, right? But in case of list, that does not happen. The list itself changes. Okay, so because the list changes, the new list, the list 2 also changes. Okay, so now what happens is when you, what if we don't want that to happen? We want totally different list, totally different copy of the list, which does not reflect the changes done to the older list. Okay, for that we use copy. So now copy is a module in Python which gives us two functions. First, the copy, which is also shallow copy, and the second is deep copy. Now let us understand the difference between both of them. Okay, so shallow copy basically creates a new object for the list. Okay, so in the first case, in the normal case, when you assign it, it points to the same list. But when you create copy of the list 1, it creates a new object of the list. But the problem is the shallow copy does it only for the first level. Okay, what do I mean by first level? So let's say you have a list of list. Over here you can see there is a list which contains normal integers 1 and 3. Also it contains a list which is 4 and 5. Okay, so basically the thing is it only creates copy of outer list, and inside it again there is a mutable which is a list 4 5. So both of the lists in case of shallow copy point to the same objects. Okay, for so in the diagram basically the list 1 and list 2 are copies of each other created using shallow copy. Both of them point to same objects 1 2 and 3. Okay, so 1 2 and 3 being mutable immutables, when I change something in one of the list, a new object will be created because the 1, 2 and 3 integers are immutable. So new object is created for that. Okay. But in case of list being again mutable, okay, the list changes. So when whatever changes we make in the A, let's say if I change 4 to 7 over here in the list of the list, the same changes will be reflected in B as well. Okay. Now this is shallow copy, right? So what happens in deep copy? In shallow copy, we are creating the copy of the outer list only, that is only first level. But in deep copy, it goes to all the deep, all the levels. Okay, it does it recursively. So basically, all of the objects are created new. So basically, when you do a deep copy, it will create a new list. Also, it will create new objects of the same values. So over here, you can see in the diagram, it created 1, 2, 3 for list 2 as well, and both are pointing to totally different objects. There is no connection. Okay. So what this does is basically, even though the list is immutable, now the list is a new object. It is a different object. Both of the lists are pointing to two different lists now in this case. So change made in the first list will not be reflected in the second list, and the changes made in the second list will not be reflected in the first list. Okay. So let us understand this better by going through some code and some examples. Okay. Yeah. So first of all, let us see what happens when we simply assign new list to the old list, the typical way. Okay. So what is happening is, our original list is this 1, 2, 3, 4, 5, 6, 7, 8 and A. We assign new list as old list. So now what is happening is, both of them are pointing to the same list in the memory. Okay, because it does not create a new one. After that, what we do is, we assign, we change something in the new list. So basically 2 means the third object in the outer list, and again 2 means the third element in the inner list, which is A. We assign 9 in place of A. Okay, so in the new list it is 9, and when we print both of them, we see that old list has also changed along with the new list. And over here we can see both of the variables have same IDs, meaning that they are pointing to the same object in the memory. So basically, if we change anything in the new variable or the old variable, the changes will be reflected in both of them. Okay. So now let's see how we can create copies. First of all, let's see how we can create a shallow copy. So we import the copy module. Okay. We again create the variable old list, and then what we do is basically we assign a copy of the old list to the new list. Now take care that it is a shallow copy and not a deep copy. Okay. So we create this shallow copy and we print. We can see both are the same list right now. Now let's see what happens when we make some changes. Okay, we execute this program. Okay, so we can see the old list is 111222333. We assign a shallow copy of the old list to the new list, and then we append something in the old list. Okay, so basically over here we can see, now when we append something, we are appending it to the outer list. Okay, and outer list are two different objects in case of shallow copy, right? So when we append something to the old list, that is not seen in the new list because the outer list are two different objects. We are changing the old list but that change is not seen in the new list because both are different objects. We have created a shallow copy. But what happens when we change something in the inner list of the old list? Okay, so basically what happens when we change this list which is inside our old list? Okay, and we are basically what we are doing is we are assigning this 2 as 33 now. Okay, over here you can see. Let us run this program and what happens, let's see. Okay, so you can see that the changes made when the append are not reflected in the new list because the outer list are two different objects. But when you make change to the inner list, being mutable, both of them are pointing to the same objects inside the list, right? So when you make a change in the inner list, that is 33, you are assigning it to the old list, but the same change is also seen to the new list as well. Okay, so basically shallow copy only creates a copy of the outer object, and inside it both of them are pointing to the same objects. Okay, so now in case of immutables it does not give a problem, but if inside it there are mutables like list which we saw in our example, it can create a problem if we want totally different objects. Okay, totally disjoint lists. Okay, now this issue is solved by our deep copy. So let us so basically copy dot deep copy, and we pass our list as an argument over here, and we assign it to the new list. So now new list is a deep copy of our old list. So what happens when we make some changes? Okay, so I have the old list. I created a new list which is a deep copy of the old list, and I am making some changes to the old list. Okay, and finally we print both of the lists. So we can see that the element changed in the old list, but the changes are not reflected in the new list, right? So basically deep copy recursively goes to all of the nested objects. Basically if you have list inside list inside list, it goes till the very end of the list and all of the objects and create new objects for all of them. So it is a totally new object. Nothing is common in both of the lists. So no changes will be reflected in other lists. Okay, so you can use this deep copy or copy functions as per your requirements. Okay, so this is it. This is deep copy. Now let's talk about multi-paradigm nature of Python. Okay,